Hello everyone. Today our topic is Reimer and Tiemann reaction. Now what is Reimer and Tiemann reaction and why is it called Reimer and Tiemann reaction? Now Reimer and Tiemann reaction is the reaction where phenols get converted to salicylaldehyde in presence of chloroform and potassium hydroxide. Now the name Reimer and Tiemann was given to this reaction in honor of the scientist Reimer and Tiemann who discovered this reaction. Now let us try to understand this reaction in detail. In Reimer-Tiemann reaction, your phenol, which is a starting material and which will get converted to a compound called salicylaldehyde. Salicylaldehyde. Basically, it is a orthoformylation reaction. Orthoformylation reaction. Orthoformylation of phenols. Orthoformylation of phenols. Now what is orthoformylation? Now with respect to this functional group over here, hydroxyl functional group, if you consider this ring, this position is supposed to be ortho position and this position is also ortho position. This is meta position and this is nothing but para position. At ortho position you can see there is a introduction of your formoyl group. This group is nothing but a formoyl functional group. Formoyl group. Therefore, we can say it is nothing but at ortho position the formoyl group is getting introduced on this benzene ring. Therefore, we can say it is a orthoformylation of phenol because the starting material is nothing but a phenol, and the reactant in this case is nothing but a chloroform CHCl3, that is nothing but chloroform and potassium hydroxide. Now let us try to understand the mechanism in detail. In the first step, the hydroxide from potassium hydroxide, it will be what? It will be abstracting this proton so that this compound gets deprotonated. So what will happen? In first step, hydroxide will donate the pair of electron to this hydrogen so that there is a formation of sigma bond between the oxygen of hydroxyl group and hydrogen, and meanwhile what will happen? The sigma bond between hydrogen and carbon will be getting broken so that we get this intermediate which is unstable because the carbon is nothing but having only 3 bonds. So however valency of the carbon is nothing but 4. So what will happen? This compound will undergo alpha elimination so that we get what? The chloride group will depart like this so that we get this compound which is nothing but a dichlorocarbene, and carbenes are supposed to be nothing but they are electron deficient species. Carbenes are supposed to be electron deficient species. Now in next step what will happen? There is going to be another deprotonation in presence of another mole of hydroxide. So what will happen? The hydroxide will deprotonate this this phenol so that we get potassium phenoxide. Here the compound is going to be like this, K plus and this phenoxide ion. And in next step what will happen? There is going to be an electrophilic aromatic substitution reaction. Electrophilic aromatic substitution reaction. And what is the requirement for the electrophilic aromatic substitution reaction? For the electrophilic aromatic substitution we need an aromatic system which is nothing but this. In this case phenoxide is nothing but our aromatic system, and we know that the aromatic ring is nothing but it is nucleophilic in nature. It is nucleophilic in nature, and carbene, as discussed earlier, it is nothing but electron deficient species. So what will happen? The phenoxide, the formal negative charge on oxygen, it will delocalize like this, so that there is a formation of pi bond, and this pi bond over here, it will be used for the formation of sigma bond between this carbon and this carbon, so that we get this sigma complex. Once the sigma complex is formed in electrophilic aromatic substitution reaction, the next step is nothing but a abstraction of proton. So in this case, the same carbon will be acting as a base for the abstraction of proton, and proton will be abstracted in such a way so that we get a stable compound like this. It is not as stable as, because still there is a negative charge on oxygen. So in next step, what will happen? There is going to be displacement of your chlorine. This is nothing but nucleophilic substitution reaction. Here this is nothing but nucleophilic substitution reaction. It can be SN2. Okay, so what will happen? The chloride will be get substituted by hydroxide. Now once the hydroxide is there, what will happen in next step? The formal negative charge on oxygen will be utilized for abstraction of proton, so that the sigma electron density from this hydrogen and oxygen will be shifting over here to form a pi bond. And what will happen? Chloride will be departing like this, so that we get a compound, this compound, which is nothing but orthoformylated phenol, or you can say in this case it is salicylaldehyde. So this is nothing but a Reimer-Tiemann reaction. Thank you.